All right, so today, actually, Christine did a fabulous job introducing the concept of the commons, because I'm going to talk to you about another iteration of the commons, but really the concept's, I think, the same. So this is really a project that NIH has undertaken. There's some history here related to the BD2K program, and they've made an investment to really try and pilot what is, I would argue, is a next generation data sharing infrastructure project. So, and this project is pretty new. We're not yet a year old. So a lot of what I'm going to show you is a 2B state, and I'm going to emphasize some use cases that we're just now working towards. All right, so why a data commons? I think you guys probably all understand this given the talks we've had, but really, we now have some technological tools that I think can be brought to bear to really support team science for really the purpose of making advanced scientific discoveries. And that's what this is all about. So I won't sort of read this definition from you, but Ian Foster uses this one and put it forward, and he's a member of the Commons team. I think it's pretty apt. So, you know, I'm also going to argue that within our specific Commons project and the pilots, what we're talking about is establishing a new model for data sharing. And what that means is the current typical state of affairs is you go to a repository database and you download your data from there, and then you work it on your own machine. But what we're trying to develop is a future state for what we think data sharing will be, where people are coming to where the data is. The data in many cases is too large, but even if it's not too large, there's versioning, provenance, security problems to be moving this around. We also recognize that there's an opportunity here in this future state where people can in fact interact together and work, be working in maybe more dynamic team environments that are supported by this technology. Okay, so I think everybody this morning has talked about FAIR, so I'm just going to gloss over this, but the FAIR concept and principles really underpin everything we're doing in this project. We spend a lot of time talking about it. It was a really, I think, seminal effort to put this forward in a publication and get the amount of community consensus that we are all going to work under this framework. Now that said, you know, the devil's always in the details, so how FAIR gets implemented in systems can be done a number of different ways, and I think time will tell what best practices are for implementing FAIR systems, but we're working on that and striving towards it. So just to talk a little bit more from an implementation point of view, and I borrowed the slide from a DCC researcher, but really, what does it mean? I mean, this is going to sound very dry, but it means data needs to be represented in standard formats. They need to have unique identifiers on them. And I say data here and data's in the middle, but really this is any research object. Okay, so by research object, I mean sort of code, software, data, anything that's really produced as a product at the end of a investigation. Identifiers have to be unique and accompany the research object. Obviously, this probably sounds like something that we take for granted, but it's not often done. And we spend a lot of time actually on Commons talking about this. Data needs to be in a standard and preferably open format. There was a publication some time ago, I should have included it in my slides actually, about the number of scientific files that could not be reopened after 5 years because they were in formats that were no longer available. I used to work in a lab where we kept Windows machines that were, you know, you're all nodding, that really needed to be end of life simply because if we got rid of the machine and that environment, we couldn't open the files anymore. And metadata and documentation need to enable data discovery, how, why, and whom they were created with clear and accessible data use licenses. This is critical. A number of people talked about provenance. Provenance is critical, but part of provenance has got to be clear licensing issues, and we are actively trying to advance that conversation within Commons and among other relevant communities taking this on, like GA4GH. All right, So the data commons I'm talking about today, and I changed some of my slides because Kimberly said it's the FAIR data commons. So I put FAIR in here. Oh, and Kimberly's not even here, so it doesn't. Oh, there you are. Thank you, Kimberly. I changed the slide because of you. So it's the FAIR data commons. And really, here are the high-level goals: to share and provide access to digital objects and data, maximizing utility. I think everybody's recognizing in the research space, I think this has been done in corporate for some time, but in the research space, data has value. It's not just a publication, and it needs to be treated as a first-class citizen. So in order to treat it that way, we need to apply FAIR to that and provide new ways for scientists to create information, reuse that data, new ways to communicate, replicate, and reuse that knowledge and data, and make it possible to solve some of these biomedical questions, which we've been frankly asking some of them for quite some time, sometimes, you know, not necessarily having the breakthrough that I think we all have hoped for. But all the while we have to do this while protecting data confidentiality and integrity. This is critical. There's a tension here, but it has to be addressed. Managing issues related to ownership, rights of access, security, subject privacy. These are things we spend a lot of time thinking about. All right, so who's our team? I actually had a acknowledgement slide, and it was so small, all the type, because this is a very large project, nobody could read it. So I've decided to just highlight the institutions here involved in our team and maybe call out and embarrass some of the people who work with me who are in the audience. So our team is called Helium. This is the Data Commons Pilot Projects is a large consortium. There are 12 awards. We were all given element names. We didn't have a choice in ours, so we're Helium. I don't know if that means we're squeaky, but either way, we're Team Helium. We're composed of Hopkins, RTI, Lawrence Berkeley. Chris Mungall is our Lawrence Berkeley representative here today. Oregon Health and Science University, University of New Mexico, UNC, Renzi Jackson Lab, and Maastricht University. All right, so what's the vision here? The vision our team put forward when we entered into this project is that we are going to treat our users as both producers and consumers of data and the commons capabilities. I think that's a critical distinction. It may sound obvious, but there are a lot of systems out there that make a distinction between one or the other. And you can, if you interact with these systems, I feel like you can tell their orientation. We're specifically trying to support both producers and consumers. And in fact, we recognize that it's highly likely that one person, the single researcher, may in fact both be a producer and a consumer. So we are looking to provide a platform as a marketplace in the building blocks. This is critical. It's very modular. So building blocks here is a word that was chosen intentionally to enable forward-thinking capabilities. And really, the primary asset of the commons resides in the data and the interactions that go on in the people that participate in the commons. Okay, so this is at a very high level, our team's architecture that we're working towards. What I want you to take away from this here is that there are a lot of pieces that are being brought to bear. We're taking advantage of a lot of new technologies. Really leveraging containers has made a lot of this possible. This is by definition a cloud agnostic architecture, meaning we're working across multiple clouds and we're trying to do that in a cost aware manner, all while providing the security that these particular data sets require. At the bottom here, let's see if I can find that. Here our data sets are represented. These actually sit in different cloud environments and they have different security requirements. So if you, just to say, MOD stands for the model organism databases, GTEx is the, I'm gonna get this wrong, genotyping of tissue expression, anybody correct me, that was done from cadavers. So the security constraints around that are very different from the MODs. TopMed is an NHLBI Precision Medicine Consortium. It's a human perspective cohorts. So the security here is very much a concern for that particular data set. And we are working closely with dbGaP and a lot of other partners around the data management and security concerns. Okay, but at its core, to kind of, okay, it looks a little different, but okay. At its core, there's things I want you to take away and notice from our architecture. Well, we're developing a web portal. Frankly, I think I just realized there's some inconsistency in the slides. We can't decide whether we're going to call it Helium share or Common share, so it tends to appear differently on different slides that I borrowed from folks. But either way, here it's presented as Helium share. Then we have sort of data represented here on various Docker images. We have high-level descriptors of these applications. I mentioned the intelligent decision and cloud-aware capability to root compute. We will provision and deploy these resources, access, write data anywhere. Here's kind of the middleware that's making this all possible in a virtualized system. So data sits underneath, but you as a scientist accessing the system don't need to know whether the top data is sitting on AWS and where that's located, because really, frankly, I'm going to assume you don't care and that we're going to handle that for you with the goal here of making these results discoverable. And that's really what this is about at this level. Okay, so again, some key components I'm just going to reiterate here to bring forward are the virtualization of the data. Right now, I actually would argue that the fact that you have to know that the data is out there and you have to hunt and peck to find them is a major obstacle. We want to further that, enable some sophisticated data discovery. A lot of this is powered by a rule engine that's programmed so that we can control access and enact policies. And then, of course, there's secure collaboration and data federation that's critical here. Okay, so I should have now into sort of the use cases. And this is the very forward-looking stuff that, frankly, we are just beginning to get into. But we have spent most of the time on this project thus far. And keep in mind, we're not a year in. Establishing the basic underpinnings of the system. And I think Christine said a lot of this work is held together by duct tape. That absolutely applies to us. We're trying to do this. A lot of the technology that has been needed to make a system like this possible is really research grade infrastructure. And sometimes we had to undertake approaches and it wasn't clear if they were going to work. So this has really been experimental. And I mean that in the best way, because I think it's been very novel for NIH to kind of fund experiments in infrastructure in this way. And so we're excited to have the opportunity to partake in that. So I'm highlighting some of our use cases here. And again, this represents a huge teamwork. This is not my work. So I'm going to do the best I can and represent these to just give you an idea of why we think creating a platform like this is important. So one of the things that we're working on at the moment is creating an Identifier Equivalency API. Now, why would we do that? This API will allow users to query any given ID or set of IDs and receive a unique list. Now, this is actually critical because right now, if you go out and probably ask a graduate student or you do this manually yourself and you start querying with an ID or set of IDs, you're going to get tons of duplicates. You're going to get stuff that's going to frustrate you, you're going to throw out. So actually getting a unique list is really important. And then we hope that that list will be accompanied with confidence scores. And really, this is a really, it may sound trivial, but this is a very complex task that's being undertaken. And I love this figure. I think, Chris, was it yours or Melissa's that we ended up?
Julie.
It's Julie's, of course it's Julie's. She makes the best figures. Julie McMurray, who's at Oregon State Health University, put this together to really show in a picture format, you know, some of the complexities of actually doing this, and there's definitely a spectrum. All right, so the other thing we're working on right now is to enable phenotype genotype queries across the system. And what does that mean? That means investigator X can come in and ask a gene to phenotype or gene to disease association and identify relationships. Again, there are a lot of systems out here that currently do this, but to do this across clouds and across the data sets that we're talking about with different security requirements and very different data structures is really what's making this, I think, an interesting use case for us. So the third use case we're working on is working with the COPDGene consortium. I don't know if you guys are familiar with this work, but this is a group that has been investigating COPD and the genetics that underpin that disease. And so really they have genetic data. They also have a huge volume of CT scans. And so we're working with them to ingest it and host it on the platform. The 3 data sets that the Data Commons pilots were seeded with don't include image data, so this is a bit of an extension, and it'll have a bit of a different architecture. We're looking to apply deep learning, especially to the image analysis parts of this. And this is one slide sort of showing from an existing project that was funded by NSF to Renzi, sort of one way that this is done. We're also leveraging a project RTI is involved in called LungMap, which enables expert curation of image data to provide that tool in conjunction with this, really try and support the needs of the COPD research community. And those guys were actually this week up at the COPD meeting. So we're really working very hard within these use cases to embed the utility within the research community. And so I've mentioned security already, I think, how many times? 3 times? This is a big issue on this project. I think it's kind of novel to try and address, to create such a forward-looking architecture, knowing we're going to have different security requirements, especially top med representing some of the most secure possible data requirements of a data set. Right now, where we are with this is we're working to establish a data governance council that's going to advise us on this and really bring together experts in the field and tell us, what are some novel approaches? Because right now, if you work like I do in the landscape of federal data management, the standards we talk about are FSMA. So there's not a lot, there are a lot of standards within the FSMA requirements, right? You're low, medium, or high. But to talk about FSMA as we're talking about an architecture like I just showed, it doesn't necessarily map on. So there are a lot of conversations going on right now about, possible creative thinkings where we can meet the requirements of FSMA, but maybe the system looks different than anything that's been done thus far. Additionally, part of the security, privacy, ethical piece of this is managing the consents that go along with these studies, and that also requires fine-grained audit trails. We are working on a proof of concept project in collaboration with GA4GH to try to make computationally accessible data use agreements so that these data use restrictions can be enforced at the system level. We are trying to identify ways to support data sharing, but also make sure that it's encrypted when it needs to be. Ownership retribution is really critical. I mentioned computable DUAs. And then implementing that at a practical level through policy-driven architecture and reusing standards like data tags, which came out of the Dataverse community, is something that we're considering. All right, so, everything these days has a GUI. So this is going to be ours. This is where I say I think this is common share. The previous slides is Helium share. We seem to change our mind on any given day what at the end of the day this will be called. If you have an opinion, feel free to let me know afterwards. But we envision this being sort of an API. It's going to sit on top of data management layer called IRODS. There will be, I mentioned, security policies and first-class citizens with metadata being considered a first-class citizen. We cannot, because of the nature of the data, enable sensitive data to be downloaded, so you will only be able to work on it where it is. That's actually an NIH requirement. Some of this data cannot be moved. So via a middleware tool called Pivot, we are looking to kind of instantiate sort of a FSMA moderate type VM possibility, portable web extension. One thing that actually an area of research that we think is interesting is tools that we could create that will limit cut and paste out of a web browser, because that's another concern when you're talking about sensitive data, audit trails, and multi-factor authentication when needed. So that's kind of an overview of what we think this thing will look like when we're done. All right, so I think I've mentioned, I left off the attribution slide because it got really crazy. It was huge, but this is absolutely in every way a team science project. There are 12 awards here, and each award has multiple institutions on it. So actually one of the greatest things about participating in this is just the diversity of people who are interacting. I do have to always we have an Excel spreadsheet of all the people and what their roles are and what institution they belong to, because it gets very complicated on phone calls. But we have, as a team, committed to working together under a certain framework. And that basically includes collaborating without imposing a particular standard or approach. Software developers have good reasons for doing things differently, and a lot of the work we're doing is experimental, so we need to try things different ways. And some of it may not work. And I think as a team, we've been very open about accepting that. We govern and manage by the open architecture of participation, which you can Google, that's actually a thing. It's a framework that we're using. We are trying our best to adopt best practices in software engineering and development. And of course, we're leveraging as much of everybody else's stuff as we possibly can, because this is not being done from scratch. And with that, let's see, questions, discussion.